All right. So, if I remember correctly, we were dealing with detecting red and black checkers at the end of last class, looking at the difference between string literals and the new keyword. Well, really, it's literals in the Java language versus using the new keyword. So, comparing red to red with the double equal sign gave us the same answer because the literal was only getting created once and put into one memory address. Whereas if we were comparing two strings, each created with the new keyword, they would have different memory addresses and therefore give us different answers if we tried to compare them with the double equal sign. That make sense? Okay, so understand that whenever we actually specifically call the new keyword, we are getting a fresh new memory address. Okay. I think I also showed you the instance of operator last time. I showed you that.
It's a good question. Let me open up
You don't remember?
the instance of.
Yeah. Didn't I say something like is C1 instance of hold on. Very relax. We're connect 4, right?
Yes.
Yeah, here's the instance of. So what's the instance of keyword do?
It takes the information from the red checker and put it to C. Or C is an instance of the red checker.
Okay, tell me what this does.
Returns an instance of red checker.
No. What does it really do?
Pull the values within checker and put them to red checker.
Why don't you look at the method that it's being used in, and that might give you some idea on how to call it. Well, what it does based on how I'm calling it.
Obviously, you did not teach us this last week.
Clearly I did. This is your code from last week.
You just typed that in.
No, I didn't. I just opened up the code from last week. This is what we did at the end of class last night. What does instance of do? What is that line I have highlighted? What does it do? It returns true under what condition?
If the checker is red.
Okay. Why? How does the instance of operator work? I agree with you because this method is called is red checker, so that kind of lets us believe this thing is probably going to return true if it found a red checker. Well, I'm returning C instance of red checker. That must mean instance of is a Boolean operator, correct?
Yes.
What's a Boolean operator?
A true or false. Or yes, no.
Okay. It's an operator that ultimately boils down to an expression whose value is a single value true or false. All right, so instance of must be a Boolean operator since we're producing a Boolean value. So when I return C, instance of red checker, it's going to return true under what conditions? Under condition that C, which is a variable, which holds a pointer, which points to some kind of checker, it's going to return true if that guy is an actual instance of red checker. So red checker here is actually the name of a class. So this whole thing boils down to true if C is an instance of this class. But notice C came in as a checker. So if I called is red checker, well here we'll look at the black checker one since that's the last thing we tested. If I say driver.is black checker RC1, which is a red checker, is black checker is taking a checker in as a parameter, a generic checker as a parameter. And we're going to return whether or not the variable C is an instance of black checker. C is a checker. Well, in this particular example, RC1 is in fact a red checker. So we're asking, is C, which is holding a pointer which points to where RC1 points to, which is a red checker, is that an instance of black checker? No. Okay, makes sense what instance of does? It allows us to compare whether a variable that holds an instance of a value is of a specific kind of instance. What's the abstract keyword do? Hey, maybe we should add an in-class test.
You cannot treat the class.
What's up?
The class you cannot like instance like the object.
What about it?
You cannot like create an object.
Okay, you can't create an instance of the object. So abstract, the abstract keyword, which we used here in checker, says this guy cannot be instantiated directly, which means that if we make a class abstract, more than likely we're creating it with the mindset that we are going to inherit from it. Make sense? So what do we do here? We create a checker as an abstract class, said all checkers have colors, and created a constructor for a checker that took a color as a parameter and sets the color. Then we made red checker, and what's red checker? Red checker extends checker, so it is everything that a checker is. And then what do? We call our parents constructor, passing it red, the hard-coded literal color of a red checker. Go ahead.
Is the extend the same function as inheritance?
That is how we do inheritance. Extends is how we do inheritance.
Ah, okay.
I mean, that's the syntax for doing inheritance.
So there is no keyword like inheritance?
That's it. Extends.
Okay, okay. Oh.
So we're saying this class extends this class. Okay? So super, that's how we talk to our parents. And when we say super, open parenthesis, pass it a value, close parenthesis, we're calling upon our parent's constructor. Our parent is checker. Checker's constructor takes a single string as a parameter. That's why we're only passing a single string. And all red checkers will pass the parent's constructor the word red. So that allows us to simply create a red checker by saying red checker RC1 equals new red checker. When under the hood, we're actually passing red to our checker constructor. Right here. Similarly, black checker, written pretty much the same way. Black checkers extend checker, and they call upon their parent's constructor, except they just pass in the literal black. Make sense? Okay. And we saw last time that this is an error because of the abstract keyword. Checker is written as an abstract class. Therefore, we cannot create an instance of it, yet we are trying to create an instance of it right here. Not allowed. Okay? Questions about any of this crap? All right, so let's then, let's look at the solution to your homework first, and then let's come and work on our Connect 4. So what was the homework assignment? Something with a deck of cards or something?
Mm-hmm. Shuffling and putting out new stuff.
All right, so let me create a new Java project. We'll call this guy card test. New class, we'll make our driver. I just saw this tonight when I woke up from my nap. I assume everybody followed in the news that Nelson Mandela passed away, right? They were showing a broadcast of his funeral, and they had a guy there doing the, for the hearing impaired, doing the sign language.
Mm-hmm.
The guy was making up stuff. Was not a professional sign languager person thingy. Was not doing real sign language. But he like looks, no, this is true. He looked like he was legit. He was up there, looked all serious and stuff like that, but was not even doing normal sign language signs. To like somebody like me who doesn't know sign language, it looked legit enough.
Mm-hmm.
You know, it wasn't like he was making fun of it, but apparently he wasn't saying anything. He was not doing any sort of translation or anything.
How did you figure that out?
I saw in the news. The news was talking about it.
Oh, okay.
'Cause I have my Google Glass on. Google Glass, if you're looking at sign language, it interprets it for you, and it just put question marks there, and says this guy's coming up with gibberish.
That's what is that?
Oh yeah, apparently there's a pipe that keeps building up pressure. The maintenance guy said it's going to explode at some point.
Thanks. So, building blowing up. So,
Alright.
gotcha.
Let's test this real quick. Okay, so we have a working program now. There's my driver. Okay, so you're supposed to build cards and build a deck of cards. Okay, so let's go ahead and build a card first. New class. Call this guy card, and cards have private string suit, private string. Actually, did you have to do values as well?
Yeah.
Okay, private suit, private string value, whatever. Let's do with strings. That's fine. Okay, constructor for a card. All right, and let's go ahead and just create ourselves some getters real quick. Where's my source? Generate getters and setters. I only want getters. There we go. Okay, so those are our cards. The card also needs to be able to display itself, right? Did I say write a display method or write toString? Doesn't really matter, I guess. So we're going to say public string toString, and this guy will return value concatenated with with suit. And I like doing this dot value. So we'll just build a little, like 2 of hearts, 3 of clubs, that kind of stuff. Okay? Alright, so that's what a card will be. Let's go ahead and just test card real quick. So I'm going to say card C is equal to new card, and I say, what comes first? Suit value. Oh, I want to have value come first. It's not wrong to have it the order I had it, but I just like it better that way. All right, so let's have it take in a 2 of clubs. Card C2 is equal to new card ace, diamonds, something like that. And then we'll do system.out.println C, system.out.println C2. And we should see our 2 cards displayed. 2 of clubs, ace of diamonds. Make sense? Okay, now we're supposed to build a deck, right? Okay.
Shuffle.
So let's create a new class called deck. The deck is going to have a field of type card array called the cards. Public deck takes in no parameters. And we need to build all 52 cards, right? So the cards is equal to a new card array 52. Now we need to fill it up with all of our 52 cards. So what I'm going to do is I'm going to say string how do I do this? Have I trying to think which methods I've shown you for splitting stuff. Have I shown you the split method yet? That creates a string array?
Think so.
No, it's specifically called split.
I think
No,
Yeah.
no. we didn't.
We've looked at the string tokenizer, but
Yes.
not at split. Okay. So we're going to say, have I shown you how to create arrays like this?
Mhm.
Yeah.
We've done that?
Yeah.
Okay. Like literally the shorthand syntax like this? This part?
Yeah,
Yes.
you have. That was when you first showed us arrays.
Yesterday was the two.
Okay, when I first showed you arrays, we would have done this.
And you showed us the brackets too.
Okay, so I did show you that?
Yeah.
Okay. Well, good. That makes this easier. All right. All right. Oh, two parentheses. All right. So, I have all my suits. I have all my values. Have we done for each loops? Like for string s.
No.
Mhm.
Haven't done that. Okay. Print I is equal to 0. I is less than the suits dot length. I plus plus for each of those. For int I is equal to, or sorry, int j is equal to 0. J is less than the values dot length j plus plus. Int pos is equal to 0 up here. And we'll say the cards at bucket pos gets a new card. The values at bucket j, comma, the suits at bucket I. And then we need an increment pos. Okay? So we're going to go through all the suits, and for each suit, we're going to go through all the values. What are we going to do? We're going to fill up the cards starting at bucket 0, then bucket 1, then bucket 2. So we're using pos, this variable, to count through our card array, filling up with a brand new card for each value and for each suit. All right. Now let's go ahead and let's create a public void display method for decks to go through and display all the cards. For int I equals 0, I is less than the cards dot length, I plus plus, system dot out dot println the cards at bucket I. Okay. So the deck constructor will build our deck, fill up the card array, then we can ask it to display itself, which should display all of our cards in a predefined order. Deck D equals new deck D dot display. Okay, so there's our deck of cards. The 2 through 10 of clubs, then Jack, Queen, King, Ace. 2 through 10 of diamonds, spades, and hearts. Make sense? All right. So last thing you're supposed to have it do is shuffle, correct? Which means that when I display actually a couple things. We need to shuffle and we need to deal. Correct? You're also supposed to be able to deal a card. Okay, so let's start with shuffling. Shuffling means that your deck should be jumbled up. They shouldn't be in a nice predefined order like it's printing right now. Okay, the way I would do this, I'm going to create an instance of our random class. Import java.util. Okay, and then I'm going to say card temp int pos1 int pos2 for int I is equal to 0, I is less than 1,000, let's say I plus plus, so we'll do this 1,000 times. Pos1 is equal to r dot next int cards.length. We've seen this version on NextNet, right? It gives a number between 0 and the number -1. We have seen this one. Okay. Pos2 will be the same thing. So pos1 will be some number between 0 and 51. Pos2 will be some number between 0 and 51. And then we want to swap those two places. So I'm going to say the cards, temp is equal to the cards at bucket pos1. So we'll preserve the card that's currently there instead of my variable called temp. Then the cards at bucket pos1 is equal to the cards at bucket pos2. Then the cards at bucket pos2 is equal to temp. So we'll do that 1,000 times. Pick two cards, swap it 1,000 times. And we don't have to worry about pos1 and pos2 being the same, because if they are, we'll just swap within itself, and we just waste our time for one of those 1,000 times. We'd have to have really, 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 really bad luck for that to happen 1,000 times in a row. Like something's broken, bad luck. All right. So now we should be able to shuffle. So it should come back out to driver. Now before I display it, we've already seen it display in a correct order. I should be able to say d.shuffle and then display it, and it should be all jumbled now. So there's our jumbled up deck of cards. Make sense? Lastly, a card needs to be able to deal. A deck, rather, needs to be able to deal a card. And this guy should return the card currently at the top of the deck. So that means I need to keep track cur top of the deck. So initially, top will be 0. After I shuffle the deck, I also need top to be 0 again. Because when I shuffle it, everything's reset, correct? All right. Then when I deal, I'm going to say card temp is equal to the cards at bucket cur top. Then I'll say cur top plus plus return temp. Make sense? So that should allow me to return one card at a time. So after shuffling, let's do a little for loop for int I is equal to 0, I is less than 5, I plus plus. We'll just do this 5 times. System.out.println d.deal. So it should boil down to 5 individual cards, 5 different cards. That makes sense?
Go back to deck for just a second, please. I just want to see the deal.
So what did I do with deal? I removed, well, I made a copy of the current card from our array of cards, where I'm keeping track of the position of that with a variable called cur top. I made a copy of it first because I needed to increment cur top, so that the next time it doesn't deal the same card again. Then I return the guy I made a copy of. An interesting thing that you could have done here is, just to kind of show you, we could have done this. Return the cards at bucket cur top plus plus. That would be an example of where the plus plus operator could benefit us. Because when the plus plus comes afterwards, we get the value of it first and then increment, correct? So if cur top was 5, this would boil down to the cards at bucket 5, then cur top would become 6. As opposed to it saying plus plus cur top, where we would become 6 right away. Remember that? And then I said, until you completely understand that, never use it. This would have been a situation that would have saved us a little bit of time in memory by doing it this way. That make sense? But if you don't 100% understand exactly how to do that, and you're not 100% confident you know exactly what just happened, don't do it. Take the extra couple lines, and be done with it. All right, so was that everything for the homework? Okay, not too bad. Everybody get it working-ish? We got it working-ish?
Can like the construct of deck, I can do pull the new cards and do shuffle and display at the same time.
Yeah, you can shuffle it in here if you want.
Yeah.
It's not a big deal. All right. Now, keeping in mind though, so did you write a display method or did you actually just do the displaying in here?
I use that to string. I mean,
Right, but did you write a separate method and then call it in here, or did you just do everything inside of the constructor?
No, I mean, like separate methods, I just call them inside the deck.
Okay, you wrote separate methods and just called them inside of deck. That's fine. And even if you did it the other way, for this case it would be fine, but just to kind of, let's assume you put everything inside the constructor. Let's just assume that's what you did. The reason that is a poor way of going about object-oriented programming is we like to give our objects abilities. I realize that's not what you did, but we like to teach our deck how to deal a card. We like to teach it how to shuffle itself. We like to teach it how to display itself so that when we go to use a deck, we can create the deck, ask it to shuffle itself, then ask it to deal some cards. Does that make sense? We're utilizing those functions, just like way back at the beginning of the class when I had the example of the object-oriented telephone on the desk over here. where all those scary wires and stuff are in there, all this crap. That's all in here, okay? But all we see is the pretty public interfaces of the telephone, the button, the handset, that kind of stuff. So when we're out here in Maine, a deck looks super simple. It's like, oh, I can create it just like that. Want to shuffle it? No big deal. Want to deal some cards? Easy. Make sense? Even though in here, it's a lot more complicated. So that's kind of your punchline for why object-oriented programming. Okay, which is actually, I think, what your paper was about, right? So tell me about the paper discussion. These pants have a highly attractant surface to whatever the material of the chair is, so they don't slide on the chair.
So you just keep getting the wedgies, pretty much.
No, actually, that's not. No, actually, the exact opposite.
Oh,
They don't move at all. There, just like pant leg goes up, everything. What's it talking about? Oh, paper.
pants.
I was talking about pants. All right, so paper was supposed to have you compare what? Compare object-oriented programming to procedural programming and problem solving. Okay, what were some of the things you were supposed to look at?
That comparison,
The history of object-oriented programming.
Okay,
the evolution of
tell me about that. What was our first object-oriented programming language?
Simula.
Okay, all right.
And then there was something like small talk. And
Okay.
Then it went off into the whole.
What was the motivation of the early object-oriented programming languages? Why did we think we needed them?
Well, originally it was to create simulations.
Okay, and why do we need object-oriented programming for that? Why did object-oriented programming make that easier for us?
Because we can reuse the objects instead of having to write the procedure for, the different steps over and over again to do one simple task.
Okay, so objects are more portable.
Yes.
We can move. Okay, I'm okay with that. You can move objects around. Let's see. Discuss the role of object-oriented programming, modern programming solutions. How does object-oriented programming compare to procedural programming? What's the difference?
Procedural is step by step, like just all listed like a recipe.
Okay.
And object-oriented, you can take things and kind of bundle them together and piece them together.
Okay. So is procedural programming dead?
No.
It's not like to say it's dead then.
Well, is it fair to say that object-oriented programming is better than procedural
Yeah,
programming?
I can say that,
Well,
but I
in a-
cannot say it's dead. I mean, no way even.
In a sense, you can say that it depends on what task you're trying to complete.
Okay.
Because either way it go, it boils right back down to procedural. Somewhere behind those objects, you have to have some procedural coding because it has to follow through certain algorithms and everything just to perform that task.
So when might a procedural language be preferred?
When you are dealing with a strict set of data.
Okay, why would the procedural language be preferred in that case?
Because you probably, more than likely, you won't have to reuse it for different tasks. It'd just be the same task over and over and over again with certain.
Okay, so you don't need to necessarily write the code with the idea of it needing to be portable.
Right.
That's fine, but does it hurt to be portable?
No.
Is object-oriented programming really harder to do than procedural programming? Okay, so why would somebody ever write something in a procedural language today rather than an object-oriented language?
Because, like I said earlier, it still boils back down to procedural. Somebody's going to have to write that procedure code for
Well,
the
but so
object-oriented.
why would somebody write something in the C language today rather than Java, let's say? How would somebody come to that conclusion that, oh, I'm going to write this in C?
Just their specific needs, or
Okay, well, tell me about that. Their specific needs must mean something. So I asked the question, is object-oriented languages better than procedural languages? And he was pretty quick to say, yeah. What do you think?
it really just depends on the situation or the problem being solved.
Okay, convince me. Give me an example when a procedural language is better.
I guess if you were like, you needed something where, I don't want to say to leave behind for somebody else, but to make it easy for somebody else to understand, where you're not pulling in different methods and, in different places, it's just all laid out right there, step by step.
And it's a complex problem.
I'm not
Right.
saying it's more efficient, but it would be easier to possibly to follow.
If you take on the problems, depends on your problem. Yes, it's perfect and it's better because now we use like graphics, stuff like that, 3D, you know what I mean? That makes the object oriented easier when you're going to use it or to modify kind of procedures.
All right, so let's say you're going out for going out to the grocery store, and let's say it's a 10-minute ride, 10-minute drive. We're going to give you two options. You can drive in a Prius. What is that, Toyota? Toyota Prius?
Yeah.
Okay. Or you can drive in a Ferrari. Which do you want to take to the grocery store? And why?
I would take the Prius just because you would probably have more space to fit all your information. I mean, all your food and groceries.
Yeah, but no, you wouldn't.
What do you mean?
You would take the Ferrari.
No, I would take the Prius because it depends on how much stuff I'm getting. I mean, yeah, the Ferrari is fancy and faster,
Okay.
but it depends on how much food I'm trying to.
You're having a Super Bowl.
Yeah, if I'm having a Super Bowl party or I got like.
Because the Prius is so roomy.
I mean, it's more space than a back seat of a Ferrari.
Their backseat in a
It's
Ferrari.
I know it's not.
It's probably fairly close.
But I mean, still, were you the one that chose the Prius?
What's up?
You're the one that chose the Prius,
I didn't think you were to go there.
You should
I
say
mean-
Chevy Aveo.
right? Something, an avalanche or something.
Okay,
I mean,
let's
I
see.
get where you're
Give
going
me-
with it.
Thank you. Somebody.
All right, hold on. This is what we're going to do. Would you rather drive a Porsche Boxster or an Audi R8?
I don't know what the RDR is. Don't make
Would you rather drive the $110,000 car or the $700,000 car?
Well, in case I get in an accident, 700. Well, there's the cheaper one.
The Audi R8 is like a $700,000 car.
Let's go with the.
But they
cheaper
both probably have pretty similar no room for stuff in them. So if given two options for a 10-minute drive, probably doesn't matter which one you take, so you're going to take the one that's fancier, right?
Yeah.
Okay? When might it make more sense to take the Ferrari or the Audi R8? Let's just assume that the $700,000 price tag probably means it goes faster.
You're on the Autobahn in Germany.
Huh?
I said when you're on the Autobahn in Germany and you can go as fast as you want.
Well, see, there you go. Gas. Is one
Okay.
filled up or not?
To make your life easier.
Well, so in that particular scenario, what I'm trying to do is drive us back to this idea of which is better, object-oriented or procedural languages.
Right.
Can you clearly say that the Audi R8 is better than the Porsche?
I mean, it might be better looking or whatever. It's personal preference.
But there's a lot of things that go into play.
Exactly.
I mean, the Porsche gets bad gas mileage, but the Audi R8 gets no gas mileage. I mean, I think the thing is a 12-cylinder with like an 800 horsepower engine.
That's doing the most.
I mean, it gets like 1 mile per gallon. I mean, it is not an efficient vehicle. It's a fast vehicle. But I mean, you probably need to fill up the tank every other day or something like that.
Both of them, they like solve my problem. Why not? I'm going with the best one.
But the best is relative. So the same is true for programming languages. Are object-oriented languages better? Well, it depends. In many ways, they might be better, but I would say in most ways, they're actually slower. Object-oriented languages are probably less efficient than procedural languages. For no other reason than there's one level of abstraction built on top of a procedural language to make an object-oriented language. I mean, C++ is the C programming language with some new levels of abstraction added to it to make it object-oriented. So when you write stuff in C++, you're still writing C syntax. Just that C syntax is being interpreted in the scope of objects, and then ultimately has to turn into assembly code, a low-level language, right? So whether you're dealing with an object-oriented language or a procedural language, at the end of the day, they both compile down to an assembly language, which ultimately translates into a machine language. So there's zeros and ones at the end of the day, any way you cut it. The path to getting to those zeros and ones is probably actually a little bit smoother the closer to the zeros and ones you are to begin with. So we might say that a procedural language feels a little bit more foreign than an object-oriented language. Granted, an assembly language, low-level language, would feel more foreign than either of them. Okay, but in the big scheme of things, procedural languages are going to be closer to machine language than object-oriented languages, even though they're both high-level languages.
But that still boils down to my point earlier from still having to put the procedural code behind the object-oriented. Well, either way, like even though us as programmers using object-oriented, we don't see it, it's still there because the person that created or wrote the tool set still had to use that procedural language.
Right, but what you wouldn't commit to is this idea that when should you write something in a procedural language? It was good you said, well, if we don't need to reuse it, if it doesn't need to be portable, that's good. But more importantly, if the solution is a procedural solution, implementing it in a procedural language will make it faster.
I thought I said that, but in different words.
I don't think so.
All right.
I don't think so.
All right.
I kept trying to get you to commit to say that sometimes it actually is better, procedural language.
I did, but I said it all depends on the situation. That's pretty much what it is.
Right, but then I asked you what the situation was. You wouldn't give it to me.
Because I can't think of one right now.
I just gave you one.
Now, after the fact.
So, in any case, procedural languages can sometimes be the better solution, even though they're an older solution. Right? Same thing's true today. We can look at, this is less of a, this is probably not as good of an example, but this is a more extreme example. Sometimes it's better to use a hand tool today rather than a power tool. If you're screwing screws in for, hanging a TV set or something like that. Sometimes having the control of being able to turn the screwdriver one or two turns at a time is preferable to the power tool that you get going crazy, strip the screw out, and then rip half your wall off because the thing had too much power to do the small meticulous task you're trying to do. So the better tool, the power tool, isn't always the correct tool. Kind of make sense? Okay. This is a motivation. Ooh, what do you predict to be the next evolution in computer programming? What comes next? What comes after object-oriented programming?
Maybe the programming language is going to be like human language, natural.
Like pseudocode.
Okay, so natural languages.
Almost the same.
Okay. How would that work? What's that actually called?
Simplicity.
Pseudocode.
Who? Well, isn't it kind of artificial intelligence?
Yeah.
The idea is if you want to program in a natural language like English, you would be sitting there talking to a computer, talking to a robot, right? Robot do this, robot do that. And that already works perfectly. I can come into my my man cave at my house and walk in and say, Xbox, on. Xbox turns on. That's it. That's the only thing it does. After that, like
Actually, I don't think so.
it's supposed to turn the TV on, it won't do it. Won't turn my TV on.
Because it's really hard to design a robot like that. I think a robot like this must be much more advanced than design a language that can be detected by a robot.
Or different
Okay.
dialects.
Okay. That's a fair statement. Could we write something in English? And so instead of typing stuff out in Java, we type it out in English, which is a less precise language, right?
Right.
And have the compiler or whatever figure out what we mean, kind of a semantic-based language. Would that come before we were able to express what we're interested in to a robot?
No.
Well, you're saying that talking to a robot is a much harder problem
Right.
than doing something like that.
Right. Because it's kind of impossible for us to design a robot like that. It's much more advanced than design a language.
I would say it's nearly as impossible to design the language that would interpret a natural language. Although I do think it's fair to say that doing it with a robot is a little harder because the one extra variable that's thrown in there is it has to be able to parse your speech. So forget about what you said. Forget about what you ultimately said. It needs to take what you said and turn it into what you actually said before it can even interpret it. So, like for instance, any of you who have any of the phones that you can talk to now, Google has them now, and so does iPhone. So if you have Siri or Google's equivalent to that, it gets crap right. 75% of the time. And, there's even a whole a thing online about when your phone misunderstands you, what stuff it types, right? You mistexted mom with some pretty funny sexually explicit stuff that was based on something very benign that you said to your phone, but it misinterpreted it. So I think that's maybe our initial challenge, but we're already getting closer and closer to that. I mean, how many of you voice dictate text messages with your phones?
Sometimes.
Really, you don't?
Sometimes.
Man, I can't.
I can't talk out loud at work. Like I can't.
Why not?
Well, no,
People leave you alone if they think you just stand around talking to yourself.
I do it when I'm driving.
Yeah.
Man, I voice dictate constantly. I'd be walking down the hall here in campus talking to my phone. Well, you learn how to do it discreetly. You just hold it up here and you're like, remind me to pick up cat food tomorrow at 3 p.m. Something like that. You're not, Siri! You're not just sitting there screaming at your phone.
Well, some idiots do, so. You see them on the bus stop. Siri! Like, what?
Interesting factoid. What's his name? Dr. Uden here on campus. He's Dean of Education. His daughter's name is Siri. She came out way before the iPhone with Siri came out. She's not old, but she's older than the iPhone 4S when Siri first came out. Guessing she's 6, 7, 8, something like that. That's a unique name, isn't it?
I have a nickname, Siri.
Really? So it's not really that unique.
Well,
Seems like everybody's kind of named Siri.
no, not everybody.
Yeah, so it really isn't that unique.
Well,
Like maybe today it's even more common than like Mike.
No, we wouldn't.
Nobody names their kids Mike anymore.
Yeah, they do.
Not now. No, it's out of favor.
Well, that's because there's too many of y'all.
That's it. So I'm just saying today there's a better chance somebody's going to name their newborn kid Siri than Mike.
Maybe, but we're not
so.
in stats class, so.
I'm pretty sure. Nobody. I mean, I think in the United States at least the names have moved towards kind of unique names.
You mean urban names?
No, not only.
Like Shaquana and
Oh, that's a whole different argument. You know, but like my brother has two sons, and the first one's name was Asher. The second one's name is Miles.
interesting.
So, you know, my brother and I'm Michael and David. Seems so boring, but those are unique names now because nobody names their kids that. I was one of like my kindergarten class. I think I was one of like 30 Michaels.
Well, mine is rare, kind of.
Really?
Antoinette.
Yeah.
I really named their kids that.
I bet you there's zillions of them in France.
Maybe, but I didn't meet too many of them when I was over there, so.
Well, maybe you're antisocial.
I'm not. You know that.
You just ran up to French people.
No, I hung out with them. I drank with them and everything else. We went to the club.
The great equalizer.
Yes.
Michael is actually the 8th most popular name in 2012.
Really?
Yeah, and in 2000 to 2008 it was the 2nd most popular. In 2009 and 10 it was the 3rd, and 11 was the 6th.
It really feels like it's out of favor.
Social Security doesn't lie. It's a Social Security website. They track how names get what.
Okay, I think we just got onto something. All the illegal aliens. All the illegal aliens. That's the only name they can spell is Michael.
Really? You're gonna say? You're gonna say that in this class, right?
Most in the United States, most of the illegal aliens are Mexicans.
Well, yes, because they're the ones that's trying to cross the border.
Well, that's it. I mean, Canadians aren't that dumb. They stay up there.
They don't want to be here.
All right. So, questions about this crap? Questions about the paper crap? I think this natural language thing is a pretty good feeling of where things might be going.
What about like something like I'm using that example, kind of Iron Man as an example, how he took the holographic figures and made them into whatever programs he wanted. I think that'd be cool.
Okay, so move away from a language in and of itself and move more to
hands-on holographic, real.
Is that still programming?
Literal. Well,
because we already kind of have that. We teach in our intro programming class, our very first programming class at the undergrad level. We use a tool called Game Salad, and Game Salad allows us to create kind of Mario type games with drag and drop without any lines of code.
right.
You know, so that's something, you know, Iron Man-ish.
But is it actually like a 3D image that
Well, and that has more to do with the presentation of it. But I mean, you're still solving a problem using, pre-created widgets. So I mean, that is a direction that programming languages are going. So it's not necessarily an incorrect answer. The weakness right now of things like that is you don't need to have anywhere near the skill set to pull off something pretty complex using a tool like Game Salad. But Game Salad, you start hitting the limitations of Game Salad pretty quickly. Whereas you don't really hit the limitations of a traditional programming language anywhere near as quickly. But it would take you a lot longer to accomplish the same thing in Java than it would in Game Salad up to a point. So the point is that it allows you to accomplish cool things quickly, fast prototyping, if you will. But it really starts falling off after that because it's trying to solve too generalistic of a problem. But I mean, it is neat for teaching intro programming classes because it allows the students like to see things dancing around the screen and colliding and explosions and that kind of crap. This is grad school. We don't do stupid stuff like that.
That's not stupid. It's fun. It's supposed to be hands-on.
Well, yeah, to the undergraduate kiddies.
I think
What's up?
you're categorizing everybody.
I've always done that.
That's true.
Stay consistent. Okay. From him?
No. I don't never smell him.
She just said you smelled.
Oh, I did it. Don't believe it.
All right. What am I doing? Oh, we got to go back to our Connect 4 now, right?
I guess so.
All right. So let's close all this crap. All right. Let me get to. So here's our Connect 4 game. Connect 4 has checkers. We already have our checkers, and then we have a board. So we need to think about what's a board. Connect 4 board, I think it's 7 columns, 6 rows.
Too much thinking for me.
Images. Connect 4. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Yeah. 7 columns, 6 rows. Seven columns, 6 rows. Each space is capable of holding a checker. All right, so 7 columns, 6 rows. How would we represent that? Using only what we know how to do right now. So that's a total of 42 spots, right?
Can 7, 6 arrays.
Okay,
And 2 for loops.
I can use 6 arrays.
And
Each array has 7 elements in it.
Mm-hmm. And then each spot has an address. Boom.
Okay, what about 2-dimensional arrays?
you can
Wouldn't it be nice if we could create a grid for this? So let's look at 2-dimensional arrays. A 2-dimensional array is actually an array of arrays. So we're going to say int array array AR is equal to a new int array. Let's do 6 rows by 7 columns. All right. Now, I'm going to spin through my array, and I'm going to do system.out.println AR at bucket I. Okay, now remember, I just said that a 2-dimensional array is actually an array of arrays. That is to say,
When I was watching one of your old lectures, I saw how you were used to be able to do that, like you
I
said.
know, so good, right? That's a good example of when the newer technology isn't better than the old technology. I like the procedural version of, it was so slick, wasn't it?
That was cool. It was just like boom, boom, boom.
Okay, so I just created, here's my 7-bucket array, AR. So the guy I'm creating here is, 6-bucket rather. So this is int array array AR equals new int array 6 rows by 7 columns. Okay, so that's the guy that's actually getting created there. Now, This is my connector guy. Okay, so this is what's actually happening.
Is that water or vodka?
Ask the player.
What do you think it is?
If it's vodka, I'm about to take it.
No, you wouldn't.
Yeah, it would.
I bring.
Huh?
I bring vodka.
This is your last class.
Yeah.
No, he's talking about next semester.
All right, so these are all memory addresses, which point to the beginning of these arrays. Each one of these guys, so 100 here is what's at bucket 0 of AR. So this guy right here is AR at bucket 0, AR at bucket 1, AR at bucket 2, AR at bucket 3, AR at bucket 4, AR at bucket 5. Okay? So what's at all of those guys is a memory address. What's at that memory address? It's a pointer to the beginning of a 7-bucket array. Does that make sense? So we have an array right here, and actually, this is actually a fib. Actually, no, it's not a fib. What was here, 212? So I'm going to say AR actually holds memory address 100, which points to here. These are the actual memory addresses of these 6 buckets. These 6 buckets have a value in them, which is another memory address. So let's say that this memory address is 587. Okay, and all the other ones are fine. Okay, so AR is a one-dimensional array with 6 elements in it. Each of those 6 elements is a 7-element one-dimensional array. So that makes a 2-dimensional array.
Hold up. Can you repeat that, please?
A 2-dimensional array is a one-dimensional array of one-dimensional arrays. So here's my one-dimensional array with 6 elements in it, right?
Mm-hmm.
Each one of these is actually an array. This guy right here is a pointer to a 7-bucket array. This guy here is a pointer to a 7-bucket array. 7-bucket array, 7-bucket array, 7-bucket array, 7-bucket array. So rather than having an array filling it up with a bunch of integers or a bunch of strings or something like that, we're filling up an array with a bunch of arrays to give us a 2-dimensional array. All right, so The first dimension of this array is in contiguous memory, just like all arrays. 100, 104, 108, that's the size of a memory address, 32 bits, right? Okay? So at memory address 100, we have the value 587, which is a memory address which points here. So that means here, this is 587. Let me shrink this down a little bit. Oh, hello. That makes sense? So bucket 0 of AR is this value, which is a pointer. This pointer points to bucket 0 of this array, which is at memory address 587, because that's what this guy pointed to. His next value is at memory address 591, 595, 599, 603. That makes sense? Each one of these additional rows will be the same thing. This is 300, 304, 308, 312. This is 1321, 1325. This is 58, 62. This is 9, 13. Get it? Okay. So, if what I just said is true, what should print out right here? What should the output of that program be? How many? Six. Should be 6 memory addresses. AR's length is this guy. AR at bucket 0's length is this guy. AR at bucket 1's length is this guy. Make sense? Just my 6 memory addresses.
This is the bucket number 0 of each one.
Well, this is sort of. These 6 are bucket 0, bucket 1, bucket 2, bucket 3, bucket 4, bucket 5 of AR. But they're also related to AR at bucket 0, 0. That guy. AR at bucket 1, 0. But AR at bucket 1, 0 is the actual value there, not the pointer to it. Does that make sense? Or did you find something good? What is it?
Sorry.
So excited about finding crackers.
Hey, look. You gotta be when your mouth is in pain.
Oh, from your braces?
Yeah.
How'd that go? Did you cry?
No,
I wish you did.
thanks.
You're welcome.
You're so endearing.
I am. I give a final exam this week. I've been giving final exams all week, actually, and I had a student text me the other day, about 2 hours before the exam, saying that she didn't really think she was prepared, and here, I'll read it to you. It was a funny back and forth, actually. Let's see. Feel like I'm gonna fail this, not good at programming. I can eventually figure it out, but it literally takes me hours or days. Any of you feel like that?
Not that I'm gonna fail at it. It's just a matter of time to figure it out.
So I respond, well, that's what she said. It takes me hours or days.
Yeah, but she just said she also feels like she's gonna fail at it.
Yeah, that's true. So my response to that was LOL. And then I said, you had better get the waterworks going for extra credit then.
Oh man. Oh, wait, you want me to read that?
No, no, I just want you to confirm.
Yes, that
Sad. Then she said, that would be funny if I cried. The mascara I'm wearing today is not waterproof. And I said, if you do it, I had better believe it. No fake crap. She goes, fake? Pretty sure if mascara was running down my face, it's real. And then I said, that only means the tears are real. You could make that happen with lemon juice.
Or pepper.
Yeah, well, a whole bunch of things. So.
Did you ever see the picture of the girl that got the spray tan and then she cried? And the spray tan is like, oh, like.
I haven't, but I can imagine.
That'd be hilarious.
I'll show you the picture.
All right, so this makes sense? Okay. So,
What? You eat hot dogs in my face?
so what if I were to print out that? AR at bucket I4. If this is bucket 0, bucket 4 of that is 0, 1, 2, 3, 4. It would print all of these guys. That makes sense? Right now, these guys are probably filled up with just zeros because they're the default value. But if I put a 1 in there for all these guys, actually, we'll do 1, 2, 3. We'll go hard code those values in. So I'll say AR at bucket 0, 4 is equal to a 1. Okay, so for each of those one-dimensional arrays, I'm going to set its bucket 4 equal to a number, 1, 2, 3, 4, 5, 6. So again, if I just print out AR at bucket I, it's going to print out the pointer to my 6 individual arrays. So there's my pointer again. If I print out bucket 4 of each of those arrays, I'll get my 1 through 6. If I print out 3 of each of those individual arrays, I'll get whatever the default integer is. It's probably 0. Make sense? Okay, so that's how a two-dimensional array is actually represented. It's represented as an array of arrays. All right, now this kind of looks like our grid, doesn't it? So I actually want a two-dimensional array of checkers for my board, right? All right, so I need to go ahead and create a class called board. And we're going to create a private card array called the board. Oh, I'm sorry, card. Checker. Nobody was going to correct me there? I was testing you. Everybody failed.
Good, we get to go home. No, I'm just playing.
All right. So we need the constructor. And we need to fill up our board. So we're going to say the board is equal to a new checker array with 6 rows, 7 columns. That make sense? All right. Now I need to go and I want to fill that board up with base values. Okay? So I'm going to make sure that the board is initially empty. So I'm going to say for int I is equal to 0, I is less than the board dot length I plus plus, for int j is equal to 0, j is less than the board at bucket I dot length j plus plus. That is the length of the array stored at bucket I in the board. That make sense?
So 0 through 5. Or
This will be
6.
0 through 5. This will be 0 through 6.
Gotcha.
All right, and we'll say the board at bucket I j is equal to null. By default, it actually was null. That's nothing. That's the object that is nothing. Okay? Now, I want to teach a board how to display itself. Public void display. We're actually going to steal this little loop here. Steal the whole thing. Okay, now we want to print out what is currently there, but if it's null, we want to maybe just print out like an E for empty, something like that. So if the board at bucket I j is equal to null, system.out.print E.
When you want it for that particular spot, or that's what it's doing?
That's what it's doing.
Oh, okay.
This guy right here is if I'm looking at an IJ is null, go ahead and print out an E.
Okay.
This guy does each column. This guy does each row. So for each row, go through all the columns. After I'm done with all the columns, kick it down a line to the next row. So this should print out 7 E's, press enter, 7 E's, press enter, 7 E's, press enter. Make sense? Okay. Let's test this. So there's my array. There's my board, if you will. Make sense? Okay. Now, we probably also need to number the columns. Because in order to play this game, we're going to be playing it in a textual way. So we need to have our board look a little bit, we need to be able to pick which column we want to drop the checker into. Because we're going to drop a checker, the checker's going to fall as far as it can fall until it lands on top of another checker. Or hits the bottom of the board, right? Okay, so as part of my output here,
Isn't it going to yell at you? So you're using I twice?
nope, because they're two different scopes.
Oh, okay.
Here's I here, here's I here. So I'll say system.out.print I. And kick it down a line after that. So now we've numbered our columns. Column 0, 1, 2, 3, so on and so forth. Make sense? Now you want to make this look a little nicer, which obviously we do, right? We're going to go ahead and we're going to concatenate on here. The tab character. Well, hold on, didn't do that for the numbers? Oh, So that's kind of my.
You never heard of that tab thing.
I just did.
Well, I'm saying before.
Yeah, so this is, well, and this is only mildly useful anymore because back when you had a lot of text-based applications, that was beneficial. We might say that a tab is actually too much in this case. So we might say 2 spaces. Maybe that looks a little bit more legit. Make sense? Okay. Now, we might even say that maybe we shouldn't put any E's. The board should look empty when it's empty.
Yeah, but you wouldn't know what spot you're in.
Who?
I mean, like,
Well, you would. We'll just print out a space.
but if you print out the whole board, it's empty.
Well, yeah, so right now the board's empty. So when I drop the 3, if I choose column 3, the checker will fall all the way down column 3, down to the 6th row, and show up right here.
Used to the lines, man. Used to the lines.
All right, so you want to leave the E's in for now?
Yeah.
All right. So now we can have the board display itself. Make sense? Well, now we need to make sure that we can actually have other types of checkers on the board. If I'm not looking at an E, if I'm not looking at a null, rather, I must be looking at a checker, either a red checker or a black checker. We have no way of getting those checkers into the board at this point, but we do intend to store checkers in our board, so we can kind of plan ahead for this. So why don't we, just for the sake of argument here, say else if the board at bucket I, J, should have named it something easier, is an instance of red checker.
Fancy.
So if that guy is an instance of red checker, then I'm going to say system.out.println R. Else, it must be a black checker, right?
Yep.
Okay. And for right now, let's just prove that we can put a couple of red and black checkers in there and they show up. So I'm going to hard code some checkers into my board here. So we'll say the board at row 5, column 0 is equal to a new red checker. We'll create a couple of black checkers there too. All right. Then we'll tell our board to display itself. And we see we have 3 red checkers here and 2 black checkers over here. Make sense? You think that's actually easier to read with the E's?
No.
Not now. Well, just like to tell where spot it's in. Like that's the only thing. Like you can't look at that and say, oh, that's that for sure.
What about there?
Better. Kind of, sort of. But
What
either
about
that's better.
pretty legit?
Yeah.
All right. Okay, so now that we've proven that our display works, we need to actually be able to make a move. So let's take out our hard-coded moves. So in order to do this, we need to be able to show a menu. So I'm actually going to make this method private now. And we're going to make another private method called show menu. And what's show menu going to do? Show menu is going to probably first clear out the screen. Let's always have a fresh menu on the screen, right? Okay. Well, how do I clear the screen?
You go through the loop and set everything and all.
Well, I mean, what I'm saying is if I want to see, like, I guess what I'm saying is I want this to not look like this. Just make this public. I want it to not show two things right on top of each other. I want there to be like a blank. See what I'm saying? So the easiest way for us to fake this is the beginning of showing every menu. We're going to go ahead and we're going to say system.out.println. I should just create a quick little for loop. For int I is equal to 0, I is less than 200, I plus plus system.out.println the empty string. I promise you this is doing it twice, but it will only look like it did it once for us because we are literally scrolling 200 lines down each time to fake it. The other one's way up here. So I displayed, then I printed out the empty string 200 times to give me a big old space between it when I saw it again. Because I don't think,
Why are we showing it twice?
well, we're going to eventually be showing the menu, then showing the menu again, then showing the menu again when we actually run this. And I don't want there to be menus on top of menus on top of menus. I want it to look like a clean screen.
Oh.
I think there might be a system.
You can make the show menu as a private.
Well, I will. It will be private. I'm just looking to see if there's a better way to clear the screen. It's not that important in this case. Let's just leave it. I don't want to mess around with that for too long. Okay, so in order to show the menu, the first thing we need to do is we need to say this dot display the current game board. Then we'll ask them which column, and then we need to read it in, right? So we need to import java.util scanner. We'll say what's this? Oh,
Dude, is this place haunted?
it is.
I'm glad you said that, like, so nonchalant.
Let's see. What am I doing? Oh, okay. So now we'll read it in. So we're going to say string call is equal to input dot next line. And then we'll just spit it back out for right now, proving that we read it in. Okay, so right now when we show our menu, we'll display the board, we'll ask them which column, we'll read in a column, and then spit it back out, proving we read it. Just ask me which column, I'll do a 0, spit out a 0. Message received. So now we know we can receive input. Okay? Now what do we want to do with that input? We want to make a move on a column. Well, for the sake of our own sanity here, we're going to assume that the column, well, let's see. I don't want to make that assumption. I don't. Let's make sure that they give us legal input. That is some number between 0 and 6. That make sense? Those are the only legal inputs here. 0 to 6. So we'll create our scanner. We'll say do all this crap while what?
While the
String
input
6.
call
Why
is
it's not
less
like
than.
between 0 and 6?
While they still have a move to make, right? So do that while private Boolean is legal move, takes in a string call, and returns, we can assume it's a number for this, integer dot, returns, dot parseInt call greater than or equal to 0, and integer dot parseInt call less or equal to 6.
Right.
Yeah, less than or equal to 6. And we're going to keep doing this while not this dot is legal move call. We need to define call outside of the loop so its scope is available in here. All right, so we need to do this at least one time. What are we going to do? We're going to display the board, ask them which column they want to make their move on, read that column in to a variable called call. I'm not going to print it out again. Then we're going to say, as long as what they entered is not legal, ask them again. As soon as it is legal, we'll tell them legal move. Good work. Make sense? All right, so we'll run this. So let's make some bad moves. So I'll try a 9. Ask me again. I'll try a 7. Again, I'll try 4. There's my legal move. Make sense? So it'll only let us make a initial legal move. But just because it's a legal column doesn't mean it's a legal move. What else must be true?
Going down.
There must be a place to put a checker, right?
Yeah.
And how do I know there's a place to put a checker?
If it's empty,
Number of
no.
row and column.
If it has a period in
If what has a period in it?
the space. The
Well, if I put a 2,
array address.
if I put a 2 on this thing right here, the checker would drop all the way down here, right? Under what condition would dropping into column 2 not be legal?
Just past the number of spaces.
If it's full. How do I check to see if it's full? I only have to look at this guy, right? I got the driver here for a second. I'm gonna not show the menu for a second. I'm gonna create a red checker. RC is equal to a new red checker. I'll create a black checker. BC is equal to a new black checker. And then I want to print out system.out.println RC instance of checker. This is a little different than we did before. BC instance of checker. What's RC? It's a variable holding a pointer to a place in memory which actually holds a red checker. Is a red checker an instance of a checker? Definitely an instance of a red checker. But is it an instance of a checker? It is. Why? Because red checkers inherited from checker. So we can ask ourselves, is the, go back to driver here, show the menu real quick. I could ask myself, is this guy right here an instance of checker? If it is, I can't go there. Right? It doesn't matter what's beneath it. Because if this guy is an instance of checker, well, if this guy's not an instance of checker, that means I have at least one space that I could drop a checker into. I might have a whole long fall, but I have at least one space. Therefore, it's a legal move, right? All right. So, back in here under is legal move, I'm not just interested in this. I'm also interested, so I'm interested in that, and oh, here, I'll do it all in one line, then I'll take it down. And what must be true. And the board at bucket bucket 0, column, so row 0, column integer dot parse int col. And not that. So as long as it's a legal column and the thing currently at that column is not an instance of a checker. Does that make sense? So I'm saying, as long as you entered in something between 0 and 6, and at row 0, column, whatever column you entered in, I'm looking at something that is not a checker. If I'm looking at something that is not a checker, then you can make your move. But if I entered in a 0 through 6, but whatever is here at bucket 0 of that column is a checker, can't make a move. Legal column, but it's already full. Make sense? All right, so I need to keep asking them over and over and over again to make their move until there's finally a move to make. And we can test that part of our code by just saying the board at bucket 0, 3 is equal to a new red checker. want to clarify this would not be a legal move in Connect 4 because it literally defies gravity. But in our game right now, it allows us to test something. Okay? See, sometimes you get those old beat up Connect 4 boards that are a little bit bent and the checkers don't fall through real great. Did any of you ever have a real Connect 4 board?
I did.
Everybody just plays digitally now, right?
No, never played it.
Really? They should come out with Connect 4 for Xbox One.
And you called me wanting to do.
No, here, this is a stupid thing. You know what they have for, it's at least for Xbox One. I think it's also for PlayStation. But they have Angry Birds.
That's because Angry Birds is fun.
It's a $60 game for Xbox.
That's doing too much when it's free on your phone.
Well, it's not really free on your phone. Most of the versions cost on iPhone and Android. But the original Angry Birds is free on Android only because Google subsidized them. That was Google's marketing thing to get a bunch of people to come over. Come get free Angry Birds. It worked.
It did.
But who would pay $60 for Angry Birds for Xbox?
Somebody that really likes Angry Birds.
Probably not. Probably somebody who has a 3-year-old and wants the TV to babysit them.
You can get the free version.
That too.
You can get the free version on
Oh, the original?
I got
Could be. Now they have 90 versions out, so it's possible they just made the original free.
like a lot of different versions for free on my phone.
Really?
Got space on
You Android or iPhone?
Android.
Yeah, Android. Google subsidizes them, so somebody's getting paid. You're just not the one paying,
Exactly.
which is all that matters, right?
That's my point.
All right. So if we move on column 3 here, it shouldn't let us go. So column 0, we should be fine. Legal move. But if I try to go in column 3, numerically we're cool, but doesn't like the fact that we have a checker there. Make sense? So we need to make another move. Okay. Now, the board should also keep track of whose turn it is. Right?
Yep.
Who's playing first, red checker or black checker? Well, who goes first?
Let the computer choose.
No. That's not the way it works.
Red.
Red goes first. Why? Gotta have fire before you can have smoke.
Oh. So that was their logic.
It's a color.
Yeah, red's the color of fire. Black's the color of smoke. You need fire before you can have smoke.
If you want to go with that logic, go ahead.
It's perfect logic.
For Connect 4.
All right, so we need to come up with a way of alternating moves. Make sense?
Yeah.
So we're going to go ahead and we're going to create a public method called play. It's going to return nothing for right now. Okay, the play method's going to keep track of whose turn it is right now. Okay, so we're going to have red checker pointer this will work. Player 1 equals new red checker. We'll have black checker pointer player 2 equals new black checker. Oh, we'll have black checker pointer. I'm coding in some other language. Everybody relax. Checker. Player. We'll start off as player 1. because red goes first. Make sense? Okay. So now we need to tell the player whose turn it is and then read in the result. So we're actually going to do all this inside of play rather than show menu like we're doing now. So inside play, we're going to create our input. We're going to need that. I'm actually just going to steal all this code for right now. So the first thing we need to do is we need to say whose turn it is. Right? So if cur player instance of, actually we don't even need to do that. We can say cur player equal player 1. Yeah, that's fine. System.out.println player 1's turn. Else player 2's turn. So we'll decide whose turn it currently is. Then we'll show them the board. We'll ask them which column they want to enter. We'll read in the column. And we're going to keep doing this over and over and over again until they finally give us a column that we are allowed to make a move in. Right? And then we'll yell legal move for right now. And then we'll say we need cur player to become the other player. So if cur player is equal to player 1, cur player is now equal to player 2. Else cur player is equal to player 1. So that should toggle between the two different players. That makes sense? And how long are we going to do this for? Right now, we're going to do this forever. Eventually, we probably want to do this until the game's over. But for right now, we're going to say forever. So while true, let current person make their move until they finally make a legal move. As soon as they make a legal move, then eventually we're going to want to drop the checker, but we're not doing that right now. Then we'll say, okay, it's the other guy's turn now. Spin back up, say it's the other guy's turn, let him make a legal move, so on and so forth. That make sense? And I'll go ahead and take out my hard-coded red checker. Oh, hold on. That's our play method. So I'm going to get rid of our show menu method. So we've basically replaced it with play. Okay. Player 1's turn. So player 1 will make their move. We'll say column 0. Player 2's turn. Say column 1. Player 1's turn. Let's say column 9. Still player 1's turn. Let's say column 8. Still player 1's turn. Let's say column 6. Now it's player 2's turn. So we have it toggling back and forth between our players. That make sense? All right. So let's then, any questions about that before we take a break? All right, let's take about a 15-minute break, come back at 8:16, and we will keep trucking.